Hey everyone, my name is Brooke Reams. Thank you for attending my Spotlight talk. This year at Dev Summit, there are a series of Spotlight talks called How We Built It, which all consist of case studies from real-world projects and solutions from Esri Services. And the case study that I'm going to talk about today is a mobile app that Esri Services developed for Allegheny County in Pennsylvania, intended to be used by hikers visiting the county's parks. So in this presentation, I'll first demo the app we developed for Allegheny County. Then we'll take a look at the software that was used to develop the app, which is called AppStudio for ArcGIS. And finally, since this is a developer conference for developers, we're actually going to take a look at some code. So before I demo the app, I first want to give a little background information. Several years ago, Allegheny County created a web application, which you see here on the slide, that allowed users to click on any of the trails in the various county parks to get information about the selected trail and to view the trail's elevation profile. The elevation profile is created using a geoprocessing service hosted in ArcGIS Online called Profile. And when a trail is selected, the polyline is sent via HTTP request to the profile task, which uses a DEM to interpolate the Z and M values, or elevation and distance, for each coordinate in the polyline. The elevation and distance values of the line are returned by the service and used to create the elevation profile chart that you see there at the bottom of the web app, where the x-axis shows the trail's distance and the y-axis shows the elevation. And users liked the functionality of the web app, but they wanted to be able to access the trail information while at the county's parks from their mobile devices. And since some of the parks have poor network connectivity, users also wanted the ability to download the trail data for selected parks so that the information could be accessed offline. So Allegheny County decided that the best path forward was to develop a mobile app for Android and iPhone users, so that's when they contacted Esri Services for help. So I'd like to show you the mobile app that we developed for Allegheny County. And the app that I'm showing you on my screen here, this is the Windows version of the app, but it also runs natively on both Android and iOS and is available for download from both Google Play and the App Store. So when the app is first launched, you can see the map view of the county's parks. And as you zoom in, you can start to see the trails. I can also see these parks in a list view, where I can see the park name, its address, the distance from our current location, some weather information, and then you can see that I can download the parks, or if I already have them downloaded, I can open the offline park, or I can delete it. And if I click on a park card, that changes the app to show the map view and zooms the map to the extent of the park. And once I'm looking at the trails, I can click on any of the trails to get information such as the distance, the difficulty rating, the elevation, the type, the blaze trail symbol. If I swipe to the right, I can see the elevation profile for this trail. Now I'm currently showing you a demo version of the app, so I can make it appear that we're actually in Allegheny County hiking along this trail to show you the user's experience when using the app. And you can see that as I hike along the trail, my current location is represented by this marker on the elevation profile. And as my position changes along the trail, you can see that the marker updates to show where I am on the profile chart. So right now I'm just about to start hiking up a pretty big hill. Now the app also has a feature called Cookie Crumb. And that allows the user to track their change in position along with the total time and distance that they've hiked. So if I start recording, as I continue to hike along this trail in the demo version of the app, you can see a new layer indicating where I've been, or my cookie crumb. And you can also see that the distance updates, as does the minutes per mile. I can choose to pause the cookie crumb feature, or if I want, I can reset it altogether. So when choosing a development platform to develop the Allegheny County Park Trails app, there were a few factors to take into consideration. First, Allegheny County wanted users to be able to download the app from Google Play and the App Store, so it needed to run on both Android and iOS. And the app needed to run natively to access the device hardware, including the network, so that it could access the map and trail data and to make a request to the profile task. It needed the GPS to show the user's current location, and local storage to store the offline maps and trail data. And finally, Allegheny County didn't have a large budget for developing the app, so it needed to be developed with limited resources. So based on all of these requirements, we chose AppStudio for ArcGIS as the development platform for this app. So what is AppStudio? Well, it's a suite of productivity tools for developing native mobile apps. And the suite includes an IDE, or Integrated Development Environment, for writing code, a tool called Player that allows developers to quickly and easily test the app as they develop it, both on their development machines as well as on their mobile devices. It also includes dozens of code samples to demonstrate how to develop various UI controls and runtime functionality, including things like how to geocode addresses, or find the most optimal routes, or identify and query features, how to update a feature's attributes, and so much more. It also includes a tool called CloudMake that actually sends the code base to development machines set up in Esri's cloud and actually creates the installation files needed to run the app on any chosen platform. So apps developed with AppStudio for ArcGIS are written in QML and JavaScript. And while everyone has heard of JavaScript, most people have never heard of QML. So QML stands for Qt Meta Language, and it's derived from Qt, which is a C-based language. It's a declarative language used mostly for developing the UI of an app. It's very similar to JSON, where objects have properties and those properties have values. The QML code snippet that's on the slide, you can see, draws a rectangle 400 pixels wide by 400 pixels high. And there's a text element that's centered within that rectangle that has a font point size of 20 and says Hello World. Now, when this code snippet is run, it produces the following output. So JavaScript is the imperative language used in AppStudio, and it's used to develop the business logic and app functionality. Now, in this code snippet, we again have a rectangle 400 by 400 pixels. This time the rectangle is green when the app is first launched. There's a button that's centered within the rectangle that says change color. And that button has a signal handler, which checks for when the button is clicked. And when the button is clicked, there's JavaScript code that checks the color of the rectangle. If the rectangle is green, the JavaScript code changes the color of the rectangle to red. Otherwise, it changes the color back to green. Now, when this code snippet is run, it produces the following. So perhaps one of the biggest selling points of AppStudio for ArcGIS is that the apps developed with it are cross-platform, meaning they'll run natively on any device. So with only a single code base, an app developed with AppStudio can be compiled to run on any iOS, Android, Linux, Windows, or Mac device. To put this into context, traditionally, if you wanted an Android app, you'd need a Java developer. And for a Windows app, you'd need a .NET developer. You'd need Swift developers for iOS and Mac, and a C developer for Linux. But with AppStudio, you only need one developer and one code base to develop one app, which will run natively across all of these devices. So enough talk about AppStudio. Let's actually open it up and use it to develop an app. In this code demo, I'm going to show you how to create the elevation profile of a hiking trail using the profile task, just the way it was done in the Allegheny County Parks Trails app. You're looking at the AppStudio for ArcGIS desktop application. Each item that you see in the gallery is an app that either I've developed or someone in my ArcGIS Online or Portal organization has developed and shared with me. I can create a new app by clicking on the New App button. Now, this opens up a dialog with several different options to get me started. If I click on the Samples tab, I can scroll through and see many different runtime samples that are available to help me get me started. So for this example, I'm actually going to start with the most basic app sample that we have available, which is under the Starter tab, and it's called App. So I just need to give this app a name and click Create. Now you can see the app is created and it's right here in my gallery. With the item selected, I can click the Edit button, and that will launch the app's code in an IDE that's installed with AppStudio called Qt Creator. So this is the most basic starter app template. You can see it has a couple of libraries imported at the top. Next, you see the app container. So this is just a container for all of my code. All apps developed with AppStudio have this app container within which all the code for the app is written. The app has a width and height defined, but that's only relevant if the app is running on a desktop machine. If the app is running on a mobile device such as Android or iPhone, it'll take the whole screen just like any other app. Now, within the app's container, you see a text element here. And that text element fills the entire parent, which is the app. The text color is black, the point size is 24, and before I run this app, I actually want to change the text to show you a unique concept called property binding, which is a huge benefit of coding with QML. So I'm going to change the text value by binding it to the width of the app. So I'll say text is app.width. Now, when I first launch this app, I should see 400 in the middle of the screen because 400 is the width of my app. So let's go ahead and run this. So there it is. You can see that the text element is centered in the app and shows the app's width, which is 400 pixels. Now, because I bound the width of the width property of the app to the text element's text value, as the width of the app changes, so does the text. And the concept of property binding allows dynamic behavior between objects, which simplifies development that can otherwise be pretty complex. So let's start developing the elevation profile app. There are a couple of things for this app that we need in order to get started. Now, the first is a web map that contains the trails layer. So I've already created the web map, which you see here on the screen. And the other thing we need is to understand the profile task that I mentioned earlier in the presentation. So the online help, which you see here, outlines the URL and the parameters that are required to run this task. So here's the URL. And if we keep scrolling down, you can see the request parameters. So these are the different properties that we need to provide, or arguments that we need to provide to the task in order to get the elevation and distance values of a polyline. To get started, I'm first going to import the libraries that we're going to use in the app. Qt is the standard library required for writing QML applications. The controls library provides access to UI components such as buttons and text fields. We'll use this library later on in the development of the app to create a busy indicator that displays while the app waits for a response from the profile task. Oops. The controls material library provides access to the materials design standard. And the Qt charts library will allow us to create the elevation profile chart for a selected trail. The ArcGIS runtime library allows us to access GIS functionality, including displaying the web map and allowing a user to select a trail in the map. And then the ArcGIS app framework libraries are specific developing apps with AppStudio, and they give us additional functionality such as making the HTTP request to the profile task. So with the required libraries imported, next we'll add the code to show the web map. So I'm going to go ahead and delete the text element and instead add in a map view, and we'll give that an ID. Now, I want this map view to take up the entire width of the app. So for the width property, I'm going to bind that to the app's width. And I also want this map view to take up half of the height of the app. So the map is going to be in the top half of the app. So I'm going to set the height equal to the app's height divided by 2. And then I need to set an anchor. So the top anchor, I'm going to bind to the parent top. And within that map view, we'll define the map. And this is where we'll show the web map. And to do that, there's a property called init URL, which we set equal to the URL of our web map. So if I go back to that web map, I can just grab the URL and copy and paste that URL into our code. So this should be all that we need to create the map. So let's save and run this. And there you can see the map that we just created showing the trails data. So next, let's add the chart object needed for displaying the elevation profile of a selected trail. And to save time, I'll copy and paste the code to create the chart, and then I'll go over it in more detail. Okay, so first, I've defined a chart view, which is the container to hold the chart. And like the map view, I've defined the width and the height of the chart so that the chart should take up half the height of the app and be anchored to the bottom of the app. Now, I don't want to show the legend for this chart, so I've set the legend visible property to false. Next, I've defined the X and Y axes. The X-axis will display the distance in miles, and the Y-axis will display the elevation in feet. And I've defined some global variables for the minimum and maximum values for each of the axes. So I'm going to go ahead and paste in those global variables. So I'll put those at the top. So here you can see the M measure minimum and max, and the Z or elevation minimum and max. So going back down to the chart view, you can see that I've also defined an area series. So let's take a look at the QML help topic for area series so you can see how that works. This is the QML help page for area series. It shows the properties and the signals for the area series QML type. Now, some of the properties used in the demo app are axis X, axis Y. We're going to use color. We're going to use border color. And when I scroll down, you can see a detailed description of the area series. And it explains here that an area series is based on a line series, which defines the upper boundary of the area. So we also need to create a line series in our code and set that as the value of the upper series property. The line series is what we're going to update with the selected trail's distance and elevation information to display the profile on the chart. So let's go back to our code. So here you can see the area series has the X and Y axis defined above, and I've set the color of the area to green. I've given it an opacity of 0.8 to give it a transparent effect. I've given it a border color of dark green that's 2 pixels thick, and I've also created a line series that I've set equal to the upper series property. So let's go ahead and run this to see what it looks like. Okay, so there you have it. The map is still in the top half of the app where we anchored it to the top, and anchored to the bottom half of the app is our chart. And we don't have any profile in here currently or any chart in here currently. It's not wired up to work with the map yet, but we will continue on with our code and eventually get that wired up. So next, I need to get access to the trails layer in the web map so I can have the app listen for when a trail feature is clicked to send the trail polyline to the profile task. So I'm going to find a new global variable for the trails feature layer so I can access this layer throughout the code of my app. So when the app first launches, the feature layer is set to null. I need to wait for the map to finish loading so that I can access this layer from the web map. And within the map object, I'm going to add code to retrieve the trails feature layer. And I can do this using a signal handler that detects when the operational layers in the map have changed. And when they've changed, I defined a loop to loop through each layer in the web map until the layer named trails is found. And once it's found, I can set the trails layer variable that I just created to the trails layer found in the map. I want the user to be able to select a trail on the map. So to do that, I'm going to add a new signal handler within the map view that will listen for a mouse click. Now, although it's called MouseClick, it listens for any sort of click on the map, even if it's on a mobile device with a touch screen. When the map is clicked, the map view's identify layer method is called and checks if there are any features from the trails layer within 15 pixels of the X and Y pixel location on the screen. So when this method is called, there is a signal handler to check for when the identify task is complete. So now I'm going to paste in the code for the signal handler. The signal handler is called onIdentifyLayerStatusChange, and you can see it's checking for when the identify task is completed. Once it's completed, I have code to retrieve the trail feature returned. The rest of the code in the signal handler acquires the parameter values that are required by the profile task. You can see here it's getting the trail length to calculate the sample size. And here, the line feature is created to populate with the trail's geometry. This will be analyzed against a DEM in the task to interpolate the elevation and distance values along the line. All of the parameter values required for the profile task are loaded into a JSON object that is required to be sent to the profile task via an HTTP request. Before I add the code to make the request, I'll first print the parameter object to the console so we can verify that a trail is identified when the map is clicked, and so you can see the values that will be sent to the task. So let's run the app. I'll click on a trail in the map. You can see the parameter values are logged out to the console. So we know that the app so far is working correctly. You notice that it's not exactly clear which trail was clicked. So I'm going to paste in code to select the trail feature that was clicked by the user. So I call the feature layer, trail layer, select feature method, and select the feature that was returned from the identify method. So let's run the app again. Now, when I click a trail on the map, you can see it's selected. And that makes it much easier to know which trail is being sent to the profile task. However, now, if I click on another trail, you can see I have two trails selected. So I need to add code to clear the trail selection when the map is clicked so that I only have one trail selected at a time. I'll also change the selection color of the trail to yellow. The feature layer object has a method called clearSelection. I'll add that before the identify method in the onMouseClick signal handler. The feature layer has a property called selection color. I'll set the property to yellow and add that just after the feature layer is retrieved from the onOperationalLayersChange signal handler. Now let's run the app again to check the results. When I click on a trail, you can see the changed selection color. Also, when I click on a different trail, the selection is removed from the previous trail. The next thing I want to do is add code that will allow me to send the parameters we created to the profile task via HTTP request, and that will parse the response to retrieve the distance and elevation values of the trail polyline. I've pasted in a network request which is available from the App Framework library and allows GET and POST requests. The network request has an ID so that it can be referenced elsewhere in the code to send the parameters. This will be a POST request, and the response will be returned in JSON format. Within the network request is a signal handler to check for when the request has been completed. This is where the response is parsed to create the elevation profile. First, the line series used to create the area chart is cleared. A nested for loop loops through each part of the polyline returned by the profile task. The X, Y, Z, and M values are parsed from each coordinate of the line part. The distance and elevation values are both returned in meters, so a calculation is performed to convert the distance to miles and the elevation to feet. I have global variables that store these conversion values that I'll paste into the code in a bit. You can see that once the conversions are calculated, the distance and elevation values are appended to the line series for each coordinate in the line. The distance and elevation values are stored in their own separate arrays so that the min and max values can be easily determined and updated along the x and y axis of the chart. Now let me paste in the global variables for the unit conversions. I'll paste the conversion variables at the top of my code with the other global variables. Now that I have the code to create the parameters required by the profile task, as well as the code to handle the response, I'm ready to send the parameters to the profile task using the network request. In the Identify Layer Status Change signal handler, instead of logging the parameters to the console, I'll instead send them to the profile task. So let's run the app to see how it works. When I click on a trail in the map, the elevation profile of that trail should get drawn on the chart. So there it is. And if I click on a different trail on the map, it appears that nothing is happening. But in reality, the network request is just waiting for a response back from the profile task. It would be good to display a busy indicator in the app to let the user know that the app is processing the request. So as a final step, I'll paste in the code for a busy indicator. You can see the busy indicator is anchored in the center of the app. It'll display in dark green. And I can use property binding to handle when the busy indicator is displayed by setting the running property to the network request's ready state property called ready state sending. So let's run the app one final time to view the results of the busy indicator. So now you can see that when a trail is clicked, the busy indicator displays showing the app is still working. The busy indicator will disappear when the response is returned from the profile task. And when I click a different trail, the busy indicator again displays. AppStudio makes it extremely easy to test apps on your mobile devices. While I'm signed into the AppStudio desktop application, I can simply click the Upload button. And this will allow me to upload my app to ArcGIS Online or Portal. And once it's uploaded, I can easily download and test it on my mobile device through the AppStudio Player app, available for download from both Google Play and the App Store. Thank you so much for watching this presentation. I hope I've been able to show you how easy it is to write code with AppStudio for ArcGIS and how it's a great option for developing modern apps that need to be run natively on different types of devices. If you have any questions about AppStudio or anything I've shown in this presentation, please don't hesitate to email me at the address shown on the slide.